Hello, welcome to part 2 of lesson 1.5, limits. And we left off with our second technique of how to evaluate limits that are in the indeterminate form if you do direct substitution. So let's get back to it. Alright, here we go. And so now the technique is trigonometric reexpression. Okay? We are to re-express the trigonometric ratio in terms of sine and cosine. If we use direct substitution, let's try that and let's see what happens with direct substitution. Alright, here we go. This is going to equal the tangent of 0 divided by the sine of 0, which is 0 over 0, which is indeterminate. Okay, so we have the indeterminate form. So now we have to re-express the technique. Let's re-express it. Here we go. So we have to look at the limit as x approaches 0. Rewrite tangent as sine x over cosine x, all divided by sine x. You see? And now let's continue to solve here. Alright, this portion right here, this is going to give me sine x divided by cosine x, sine x. Okay? And in this case, my sine x's cancel out. 1, 1. Which is 1 divided by the cosine of x. So we have the limit now as x approaches 0 of 1 over the cosine of x. Now we can go back to direct substitution. Okay? Let's do that. So now substituting 0 for x, we're going to get 1 over the cosine of 0, which is 1 over, well, what is the cosine of 0? 1, which equals 1. So there you go. Alright? So the limit as x approaches 0 of tangent x divided by sine x is 1. Okay? Alright, let's go forward. Here we go. Let's keep it moving. Alright, now we have the squeeze theorem. Alright, in the two special trig cases. I'll prove these in class. I'm not going to do it here. Alright. However, I do want to make a comment. This special trig limit is important. Okay, you need to memorize this. It's a must. Along with this one right here. Okay? And these two special trig limits can be proved by using something called the squeeze theorem, which we'll talk about and discuss more in class, okay? All right. And we'll do the proof. We're going to do this proof right here in class using the squeeze theorem. All right. Let's go forward. Okay, so now let's consider the tangent. The limit is x approaches 0 of tan x over x. Plug in 0. And this, of course, is indeterminate. So we're going to have to use the special trig limit in this case to evaluate this limit here. Let's do it. And so the limit as x approaches 0, rewrite tangent x in terms of sine x over cosine x all over x. okay? Which is going to equal sine x over x cosine x. Now we can take the product here in my denominator and split it up. In other words, look at x times cosine x separately, like this. So look at sine x over x times 1 over cosine x. You see that? Because this is sine x times 1, and this is x times cosine x. So split them up. Sine x over x, and then 1 over cosine x. Split them. And now evaluate the limits separately. And so we can look at the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine x. Well, consider the first one right here. This one here is one of the special trigonometric limits. The limit as x approaches 0 of sine x over x is 1. Okay? This is going to give me 1 times. Now over here, do direct substitution. Put in 0 for x. So that's going to give me 1 over the cosine of 0, which is 1 over, what's the cosine of 0? 1. So it's going to be 1 times 1, which is simply 1. And there you go. So the limit as x approaches 0 of tan x over x is 1. Okay? Last problem. Last one. All right. The limit is x approaches 0 of sine 2x, double angle formula, double angle here, over x. Well, let's take a look at it. If you put 0 in, you're going to get the sine of 2 times 0 all over 0, which is the sine of 0 over 0, which is 0 over 0. Again, that's indeterminate. That's not going to work. So we have to rewrite sine 2x. Two ways to do it. Way one. You need to recall from pre-calculus that the sine of 2x equals 2 sine x cosine x. And so this is going to give us now the limit as x approaches 0. Do not write sine 2x, write 2 sine x cosine x. 2 sine x cosine x, all divided by x. Split it up like we did the last problem. So this is going to give me the limit as x approaches 0 of sine x divided by x times the limit as x approaches 0 of 2 cosine x. Now you evaluate each of them separately. This one here, this equals 1 times this one here. Well, let's see. You put in 0 for x right here. You're going to get the limit as x approaches 0 of 2 times the cosine of 0, which is going to equal 2. Well, the cosine of 0 is 1. 2 times 1, which is 2. So it's going to be 1 times 2, which equals 2. And that's the answer. The answer is 2. So the limit as x approaches 0 of sine 2x divided by x is 2. But that's only one way to go about it. Here's another way. You might like this one also. Watch this. Now, way 2. The limit as x approaches 0 of sine 2x over x, you can multiply by 1. Because 1, that's the multiplicative identity. Doesn't hurt a thing. So multiply numerator and denominator by 1. Okay? Let's do that. Let's multiply by 1. And so, what we can do, we're going to have the limit as x approaches 0, sine 2x over, I'm sorry, wait, this should be x, pardon me. Make that an x, not a 2. X, there we go. Over x, let's multiply by 1 now. Here's how you do it. Times 1. In this case, this is how you write 1. That's 2 over 2. Why? Because the argument right here is 2x, 2. To multiply by 1. 2 over 2. And if we do that, we get the limit as x goes to 0 of 2 sine 2x all over 2x. And now separate it again. We have the limit as x goes to 0 of sine 2x over 2x times the limit as x goes to 0 of 2. Well, the first one here, this one right here, sine 2x over 2x, that goes to 1. That's the special trig identity using the squeeze theorem. Special trig limit, rather, using the squeeze theorem. That goes to 1. And this one right here, as x goes to 0, the limit goes to 2. And 1 times 2 is 2. So there you go. There are your two methods. Okay? All right, well, that's it for the limits lesson. See you next time. So long.